right here. You use your calculator, okay? But it says, whoops, find the average distance from each observation from the mean. We did that. Average the distance by dividing by n minus 1. You're going to say, well, Mr. O, why do we divide by n minus 1 instead of n? And I'm going to tell you, it's a very complicated concept and a very complicated idea, but I want you to take my word for it now, and it's something that we'll talk about later in the course. So the standard deviation, S subscript x, is the square root of this averaged squared distance. So on your formula sheet, it will probably look something like this. You guys have the formula sheets. Okay, 1 over n minus 1 times the sum of all of these things, xi minus x bar squared. Okay, there's your standard deviation formula. Okay, that's on the formula sheet for the exam. Okay, but again, you're never going to have to plug that in. Okay, here, this is really important. When you are using a calculator, and I'll show you in a minute, you're given a choice. Either this or this. We choose that. Okay, that's the sample standard deviation. The other one's for the population, and we don't have all the values, we don't have the distribution for the population. So I can show you how to find that. Let's go to stat. Let's run those first one variable statistics again. And if you look here, okay, here is my 9406. That is where we take the sum of all of those x squareds. But here are the two that I can choose from. Standard deviation, and then for the sample and for the population, we use S subscript x. You're going to be given that choice. S subscript x is what we use. Okay? So let's see what we have on the next page. So standard deviation measures the spread about the mean. Only use if the mean is chosen to measure center. Center and mean and standard deviation go together. Median and IQR go together. Okay, we're going to talk about that in a minute. Oh, guys, we are almost there. I know, these sections are long. I wish we were in school for it. So S subscript x is always greater than or equal to 0. If S subscript x equals 0, there's no variability. That means you have a set of values, 5, 5, 5, 5. There's no average distance from the mean, 0. Very unusual. You don't see that very much. S subscript x has the same measurement as observations. So if we want to find the standard deviation of chicken sandwiches, and the chicken sandwiches are measured in grams, standard deviation will be measured in grams. Okay? Make this an x bar, make this a S subscript x. They're not resistant. A few outliers can make your standard deviation very large. Okay? So, there will be some problems that you'll practice doing standard deviation on your homework, and I'm guessing there'll probably be a check your understanding as well. Okay? Yeah, they want you to find the mean and that kind of stuff. Whenever you do this, I'm going to tell you, you can always use your calculator to add these up, okay? And the way that you do that is you hit stat and you hit edit and you type them into either L1 or L2. And then you hit stat and you arrow to calc, and then it says one variable stats, one variable statistics, hit enter, 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 and it'll give you your mean, it'll give you your standard deviation, okay? So don't ever do that out by hand. I know they say to do it once. No. All right, so how do we wrap things up? Well, we wrap things up by looking at when do we use the mean and standard deviation? When do we use the median and the IQR? Well, it says it right here, okay? Median and IQR use if you have strongly skewed or if we have outliers. These are resistant to extreme values. Extreme values don't change this much. Mean and standard deviation, it's very sensitive to extreme observations. It can be misleading. Now, you can look at all your statistics, but there's no substitute for looking at a graph, okay? Numerical summaries report facts, but don't describe the shape, don't describe highlights, peaks, or clusters, okay? So here it says the following data show number of contacts of a sample of high school students had in their cell phones. Okay, next page. Jeez, what do they ask you to do? I don't know. It's a great question. Let me see in the book if I can find out what they wanted you to do there. So I guess they want to know, does the data give convincing evidence that, let me see, does the data give convincing evidence that one gender has more context than the other? So I guess I wanted you here to do the standard deviation stuff, but you know what? We're gonna have enough examples of that. I don't need you to do that. All right, so let's wrap things up. Choosing measures of center and spread, we talked about that a little bit, okay? So we have, let's say we had a data value, a set of data values. 1, 2, 3, 4, and 5, okay? And I want to find the mean, I want to find the median, and so on. I could, with the mean, I could find standard deviation if I wanted to. And with the median, I could find IQR if I wanted to, okay? The mean and the median here are going to be the same. If we add these up and divide by the middle, we're going to get a mean of 3 and we're going to get a median of 3, okay? And then our standard deviation, I don't think I have that done out, and that's okay. But my IQR, we could figure that out if we wanted to. So I guess I'm concentrating on those. Now, if I have 1, 2, 3, 4, and 500, what's going to change? Which ones of these are going to change? Okay. Let's do the IQR for the heck of it, okay? For these values, my IQR is 2. So now when I go over here, my mean, my median, and my standard deviation and my IQR, the mean, the average here, well, boy, that's going to be something, I don't know, it's probably somewhere around 1,000. Oh no, it's 500, so it's not 5, I made that 5,000. My mean will be somewhere around 1,000. And my median, oh, that's still 3. Median, still 3. Standard deviation, going to change big time. Yep. IQR, oh, that's still 2. So it shows you how an extreme value has a large effect on these two, but doesn't change these. Those are the same, and that's what I tried to show you with, the resistance and that type of stuff. So I think we've done a pretty good job of section 1.3. I'm going to give you these questions to do out of the homework, but my guess is that I probably posted something about these. However, in this section, these are the ones that you have to do. 79, 81, 83, 87. I try to give you mostly odds. 89, 91, 93, 95, 97, 103, 97, 103, and then we go 105. And then I go 107 to 110. Okay, so those are all the problems that are going to be due in this section. By now, I would have talked to you about how we're going to quiz and test, and I'm not sure yet. Okay, but that finishes up section 1.3. So hopefully that makes sense. If not, you guys send me an email. Okay, email your questions. Hoping to have some live sessions as well, but email me your questions, especially if you don't understand some of these. I'll do my best to explain it to you. All right? We're in this together, guys. We can do this, and we will do this.